So with these questions, I would like to introduce our first panelist, Agostino Nickl. Agostino Nickl is a doctoral fellow at the Institute of Technology and Architecture at ETH Zurich. He received the Architecture and Technology Doctoral Fellowship in 2021 at the Chair of Digital Architectonics Research Group, supervised by Professor Ludger Hovestad and Professor Vera Buhlmann, who will be joining us tomorrow as well. Before joining ETH, he worked at Arup Studio in London in an interdisciplinary design innovation team and taught architectural design at the Oxford School of Architecture and Landscape Design. He also taught video game urbanism theory at the Bartlett School of Architecture, UCL, where he received his master's degree under Professor Laura Allen and Professor Mark Smout in Unit 11, where his work was awarded the Sir Bannister Fletcher Medal, the Bartlett School of Architecture Medal, and the Saint-Gobain Innovation Prize. I think he got all the prizes there. Agostino's talk is titled Questing the Open Expanse, Exploring the Unworded Vectorial World of Large Language Corpora. Take it away. Thank you.
Yeah, thank you, Adil, for introducing me. I did not get all the prizes. It's my pleasure to speak today about a topic which is very close to my heart, it's very close to my PhD, and it's about the idea of the quest, the architectonic quest. And what I'm going to try to do in my research and what I'm going to share with you today is to think about how bridges can be built between architectural research and artificial intelligence. And as all of us today, I'm excited about playing models, because I think that these are the very models that play up and make up our world. So the very chair that you are sitting on right now exists not only as this like mass-produced technical object in this room, but it's also as a digital object in the web. So here I found it on Kit Superstore online, and you can download it from there. And so this is not really news for anyone who has ever been tasked with designing a building. Things that we find online or in our building information systems, they become things that we select and fabricate. And then from this kind of sheer multiplicity of technically fabricated objects, then there's still the moment where somebody goes on site and makes them to fit a very specific location in a very specific place. And I think that this translation, because between the technical and the digital, are things that don't only work one way. They kind of affect the source domain where they're coming from. And I think that this becomes ever more pressing because the so-called digital world became a whole more interesting over the last couple of years, more vibrant and more alive than we could have ever imagined only a decade ago. In the 1960s, the philosopher Gilbert Simondon invited us to think how technical objects reticulate our world anew. He writes, techniques return to the world to ally itself with it. A new reticulation establishes itself, chosen by techniques privileging certain places of the world in a synergetic alliance of technical schemas and natural powers. The mediation between man and the world becomes itself a world, the structure of the world. Now, the temporary philosopher Yukui, he builds a lot on Simondon in particular, and then takes this a bit further and think about what does that mean for the digital age. As we have relational databases like SQL, which I tried to show, where we can start making queries in structured language. But today, I think that the digital world is more than the renders that we can see on our screens, and it's more than the kind of things that we can see in mixed reality headsets. The world is newly reticulated not only through technical and digital objects, but through a very special kind of digital object, which I like to call the vectorial object. And it would look something like this when we apply the clip model, which is, for example, behind DALL-E and behind Stable Diffusion, to the chair that we are looking at. And so clearly, this indexes a space that is hyperdimensional and that lies well beyond what we could normally visualize or simply query. And there's not even a question that we can ask because there's not a structural a structured language in which we could ask that question. And yet this vectorial mode of existence, I think, affects every single digital query that we do. So how do we make sense of this digital reticulation and the vectorial reticulation of the world? And there's this very beautiful quote by Simone Weil, writing, "I have no way of satisfying myself about questions concerning the world, because, such as what this piece of paper is. Therefore, I must invent a new kind of analysis unknown to logicians, an analysis that is the source of an orderly progression. But isn't that absurd? What could such a progression be based on? It must be based on the world." So we could say with this, we thus observe in the world is firstly our method of questing it. And so today I want to present an attempt at what such an orderly progression might look like. Because that which cannot be queried might allow for being quested. And where the structured query knows its way, the quest does not, but there the method and the path needs to be actively found or invented. And so if we want to learn about this new vectorial reticulation, then we need to go on a quest. But how to think of such a quest? How could we use code in such a quest? And when does such a quest become epic? So, of course, we know of the epic quests in antiquity. So, for example, the Gilgamesh epos, Homer's Odyssey, Virgil's Aeneid. And then, of course, today we know about quests from epic science fiction movies or from video games, where the player follows missions or quests, or as well from fantasy novels such as The Never-Ending Story. Both the query as well as the quest harbor the Latin term querere, to seek, to search. But as Heidegger tells us, etymology can only go so far. So there is a way of approaching this slightly obliquely, and that's where like a small serendipitous encounter came handy, which is about a year ago, I bought this smoker pot. And it's actually quite bad. So like the coffee that it makes always tastes incredibly bitter. And like I left it on the shelf since then. I bought another one. But on the packaging, it has this very beautiful quote by its designer, Aldo Rossi. And it goes, if I translate from Italian, "In life, as much as in architecture, if we search for a thing, we do not search only for that thing." With this, I think that we can start thinking of the quest as something that cannot help to exceed the thing that is in question. So how might this look like today? Questions, it's kind of obvious, but actually it's striking to think about it. Questions only really exist in language, writes the philosopher Werner Hamacher. But also, if there is such a thing as a vectorial world, there's no getting around language properly. So today, the most transformative neural nets are transformers that work with large language. And maybe we shouldn't be surprised. Natural language processing is the field that allowed large language models to come about. Processing natural language allowed not only these models to become intelligent, like as reading in between lines of text, but also they allowed to become foundations models that we can use for all sorts of different applications. And here's a remarkable video of how Ilya Sutskever, who is the CTO of OpenAI, speaks about how AI learns to see through text. Let's see if this works in terms of the sound.
Things are much easier.
Not that great, but I can just make it on full.
Learn from images and diagrams and so on. But I claim that you can still learn them from text only, just more slowly. And I'll give you an example. Consider the notion of color. Surely one cannot learn the notion of color from text only. And yet, when you look at the embeddings, I need to make a small detour to explain the concept of an embedding.
Yeah.
Every neural network represents words, sentences, concepts through representations, embeddings, high-dimensional vectors. And one thing that we can do is that we can look at those high-dimensional vectors and we can look at what's similar to what. How does the network see this concept or that concept? And so we can look at the embeddings of colors. And embeddings of colors happen to be exactly right. You know, it knows that purple is more similar to blue than to red, and it knows that purple is less similar to red than orange is. It knows all those things just from text. How can that be?
Yeah, this I think was very striking the first time I saw it, because it's incredible how language allows for these very complex relationships to come through, even though you might think that they might only be internalized by looking at a multimodal training approach. But if we take all of these things seriously, then the brief just became way more complicated, because our quest is vectorial as much as linguistic. It must not only quest language, but also question language itself, to not get into a mode where language becomes a totalizing reality, or, to quote the feminist philosopher Luz Irigaray, giving into an unforgiving system in which everything is snared in sameness. So rather than using language as a means to technocratically dwell in the world, Luz Irigaray invites us to quest a different kind of place. She writes of the open expanse, to make sense of how this expanse might unfold indefinitely, gathering all things together, relating them one to another and each to each, as if nothing were happening. And this applies to our quest too. If we trust in this assumption that AI and large language models in particular reticulate our world anew, and if this reticulation arises between things that are mathematically encoded and then modeled in language, then this cannot be quested in language alone. And Irigaray finishes her book by introducing only one character who seems somewhat successful in approaching this open expanse. And this is a venturing poet. Alone, ever alone, the poet runs the risk of moving out beyond the world, and from there of inverting the open until the ground of the groundless is reached, saying yes to that which calls him beyond the horizon. He can trust in nor heaven, nor earth, nor mouth speaks his pathway. He thus must leave the world, remaining all the while mortal, holding nothing back, giving themselves up to the measureless open. So we can try taking the lead from Irigaray's venturing poet. However, he is quite an elusive figure, and the book ends quite soon after these sentences are written. So we must take cues from other venturing poets. And there's one epic poem in particular that seems to be quite close to Irigaray's venture in the open expanse. And it concerns too a venturing poet who embarked on a venture about 700 years ago. This poet visited an abyss and the clouds, staying all the while mortal, and versing his quest into versicles. And this is Dante, the poet pilgrim, and his Divine Comedy. In its both mathematical and literary abstractness, the Divine Comedy might help us as a model to think of what such a quest might look like today. It follows a striking mathematical model that actually, and this is GPT's attempt at modeling it, which is not quite right, but but still not bad to kind of like show how it works at a very high level. Where like Dante would kind of go down the spiraling descent to hell, where then at the very bottom he would find the devil himself. Then the whole thing kind of inverts and becomes a hill to climb, which is purgatory, and then as purgatory ends, he's being picked up by Beatrix and then flies through the heavens. So let's look at these central elements of this epic a bit closer. So first, we have this very precise mathematical topography that we're dealing with. Then this contains, well-ordered, all the things to learn, which are in this sense, or in this story, conveyed by souls. Third, we have Dante, the poet pilgrim. And because the quest is quite a scary endeavor, there are fourthly guides like Virgil and Beatrix who take care of him as time unfolds. But there are, of course, also very obvious differences to what Dante is doing and what we might be doing. Dante looks at the afterworld, while we are trying to quest the vectorial world that surrounds us as we speak today. Dante is mainly concerned with human souls, while we are looking at the digital and vectorial objects that surround us today. So let's think about how these elements could work for our quest. The hero is, of course, intrinsically linked to the idea of the quest. And here, especially, Campbell's hero journey comes to mind. But musing on some notes by Virginia Woolf that equate heroism to a disease that one gets from eating rotten sausages, which is botulism, Le Guin writes, "We are told that a heroic stories shall be like a spear, hit a point and require a hero. But this hero has a real problem, because after Irigaray, the hero is so shut up inside himself that to attain anything from outside is a very difficult task." And so next to the botulism equation, Virginia Woolf writes, "A hero is also a bottle." And Le Guin then picks this up and then continues this and writes, "I propose the bottle as a hero. Not just the bottle of gin or wine, but bottle in its older sense, of a container in general, a thing that holds something else." And so we can think of a hero as being no one in particular, but as someone or something that collects things and then keeps them safe. And I think that this is quite close to we might think of ourselves as architectural researchers. Now, we said that the Vectorial world might be less concerned with human souls, as it's the case with Dante, but more with bodies. Corpora containing millions of digital objects, which are their corpuscles. And if we are to gain some access to the Vectorial world of today, then it's probably through them. Because each of them floating about in the world and in the World Wide Web taught the intelligences of today how to read, how to sculpt, and how to imagine the world. Now, digital objects, they share many different modes of existence, because the web is multimodal. It includes books and sentences, sounds and scans, database entries. Of course, as a sole researcher, with like this MacBook at my disposal, which sometimes works, I can only accommodate a small fraction of them in a curated corpus. So what to choose? So primarily, a scholar works with books. So I sourced the books for this experiment from 3 sources: from the public domain from Project Gutenberg, freely licensed books in the Internet Archive, and then open access books from the Open Library. And then using my research plan, after a year at ETH, you write a research plan, as a kind of digital fishing net, I would then go and fish in this kind of sea of, I think I had 22 million book titles, the kind of 10,000 books that I actually wanted to have in my corpus. Then, next that I want to work with are 10,000 things. So these things are considered precious or not. Each of them are scanned with phones or with scanners, and then they are turned into digital objects. And they might be in museums, they might be in on the curb, they might be in the forest or in a city, and they're all hosted on Sketchfab. Then I work with 10,000 sounds from and all the materials from the ETH Material Archive that catalogs material knowledge. And then recently I also added 10,000 videos, aerials, poems, and finally artwork. So it's really a massive corpus, multimodal, spanning all sorts of different media. Now, to make all these different types of corpuscles participate in the vectorial world of neural nets, they need to be translated, encoded and vectorized into a domain that can accommodate all of them. And the high-dimensional space of language, indexing sentences and words, might be such a generous place. And often the intelligence of the uploading users, they made a start. So they gave things titles and descriptions, even though they're not always in English. Then, with varying degrees of success, also artificial intelligence translates between domains, such as image to text or sound to text. And so I think that no technology by itself is enough to pursue this role. Rather, we need to orchestrate a whole constellation of technologies into roles that can help us with this task. So I set up a kind of a technical ensemble where there is a lector, and the lector reads all the, reviews all the text. Then the translator gets to work, translates all the texts that are not in English. The auditor gets to work on all the sounds. And the inspector then looks at all the colors of the materials, and looks at the 3D scans, turns them around into all the different configurations. And then all of these things Okay, this did not work. Are then joined in sentences and text. So there was a bit of a hiccup here. However, through this kind of process, by having this chain of different neural nets that pursue different roles, we get to a point where everything sooner or later can be circumscribed as a text and then can be encoded in a neural net. So then now everything is made out of the same stuff that language speaks with and then thought thinks with. And everything thinks in this sense, maybe not necessarily how Heidegger would see it as everything thinks, but then at least everything thinks words, if not world. Now we have these millions of sentences. We have descriptions, circumscriptions, titles, circumtitles, names, and definitions. However, we cannot really count on these words. In order to count on them, we would need to make a dictionary of all of these things, and then assign each word a number. And then by doing that, it becomes a token. And then we can think of this as a space where every token is a dimension. Against this dictionary, every sentence is a point, and basically a simple frequency value. And so encoded by our technical ensemble, if it's working, everything starts to be translated into this domain. And in doing so, we forget all the sentences once we are at that point that these things were formed, right? The sentences are literally suspended in midair. All of them are of the same kind. They are points in hyperdimensional space. They are hyper-objects connected with everything that's expressed in a tokenized language of our corpus. We can count on them now. So language becomes spacious. Where do we enter? Now that we have encoded all of these things, we need to find a way of thinking how they might actually be in the world, how they are connected to each other. Irigaray writes, they are things and are things in relation to each other. Only when resettled in good order within the open expanse. So how can we think of the order between things in their suspended state? And can the relations between these things, when resettled in this good order, form a crystalline mapping of a possible region of this open expanse that we are interested in? So where Dante, the poet, fashioned a precise model for all the souls that he wanted to encounter on his quest, we let our corpuscles turned vectors self-organize into a map of the vectorial world. Working in code, this must not remain an abstract idea because we can actually code it, we can make it real. But we need a mechanics that provides this kind of ordering, which has to share some of the cosmical moments in common with with the mechanics that order the world. And so we have this kind of cosmotechnical algorithm, which is the self-organizing map, which we can train, like here, on vectors. And if we then often used for classifying things, for clustering things, we already saw some examples, but we are on a quest. And so we are into the idea of this as a map that helps us draw this kind of world, but also as a model that in its modelness realizes the world that it is modeling. Now, if we look at this training of all of these millions of things, we see that we don't see anything. And that has to do with the fact that we are in a dimensionality that's completely outside of what we can visualize in 3 dimensions. So every attempt to see what is going on requires a reduction of dimensionality. And then we can start seeing how this neural net starts to adapt to the vectors that are shown to it. Now, after the training, we then select a model to avoid the over and underfitting that we also heard today about, that is kind of smooth and retains the relations without getting too discrete. Just like in this case would be 18 or 19. After we have obtained this model, each node in this net now becomes a cell which is capacious of holding things that are nearing each other. And when dealing with these hyperdimensionally encoded text corpuscles, this self-organizing map is not mathematically only topological. It literally draws together topoi, which are commonplaces. So when we look at the text that is contained in all of these things and the words that are contained in each of these cells, we can see that things that are related to each other are very close to each other. And there are very different kind of regions as we move across this map. Now, where PCA, like the principal component analysis that we use to actually visualize this in this vibrant colors, shows us these kind of regions, allows us to actually show a veritable topography with valleys and hills and peaks and troughs. So I'd like to think that Robert Venturi would say that this is PCA in plan and mean in elevation. But we have this multiplicity of possible valleys and hills, peaks, but where to go and what to see? In such a network of high points, key points, high places, writes Simondon, there is a primitive lack of distinction between human reality and the reality of the objective world. These key points are points of contact and mutual mixed reality, places of exchange and of communication. But this is not really a stable ground, and looking at it alone does not really make any kind of communication arise. So we need to step in. And if we take this as a kind of imaginary model, then there is not really a privileged beginning from where to start, as Michel Serres writes. Rather, there are multiple entry points, ramifications among weighted links between vertices that we can explore. Now, an infinite amount of possible quests are possible in this topological map, which we could not ever exhaust in a lifetime. So how to trace kind of meaningful paths through this topoi? Quests are known for being scary, like whether that's a video game or whether that's a story, and they normally get scarier along the way. In the beginning of the Divine Comedy, Dante finds himself in the middle of a dark wood. In the wood, writes Heidegger, there are paths, they are mostly overgrown, that come to an abrupt stop when the wood is untrodden. They are called Holzwege. When Dante himself finds himself in a gloomy wood astray, it's just a couple of lines until he is assured to find someone who leads all wanderers safe through every way. So I'm not actually rhyming this. This is actually how it's written in Divine Comedy. And then again, a couple of verses later, he meets Virgil and Beatrix, who know sections of the topography well and take care of him. But who could be a guide within this model? Authors, in fact, make great specters. Their whole oeuvre can be a guide or some of their selected works only. A guide shows us a way in sequence, unfolding in one dimension. And we can model such a guide quite similarly to our topography. So here is a one-dimensional self-organized map. And as we spoke of Aldo Rossi earlier, I now imported and cleaned all the books by him to train this guide for this leg of the quest. And trained on any corpus, this guide now learns how to show the spectrality of all of this corpus at a given amount of resolution. So these are like 16 cells. And now the cool thing is that we can start mapping these things to our topography as long as it's vectorized accordingly. So these are the kind of places that Aldo Rossi would go and visit in our model. And every spectrum, every character has their own way of navigating this world. So the question is, how do we translate, how do we read from one place to another using our topographic map? And this is, I think, by reading in a notebook. Because a notebook is far more than a receptive surface. Like I'm presenting from a notebook right now, but also the notebook is a way where we can record things, we can save things. So in that sense, it can be a travel log. Illich, who's a scholar who wrote already some time ago about concepts that are very close, feel very close to us and our kind of idea of digital literacy, even though this was written way before personalized computers were a thing. He writes about the act of reading as a physical activity, picking, bundling, harvesting, or collecting. And this was especially true in the 12th century. When Hugh reads, he harvests, he writes. He picks the berries from the lines. Soon after, there was this massive turn from this bodily monastic way of reading to a scholastic kind of moment of reading, where people no longer approached the book as a vineyard or a garden or a landscape for an adventuresome pilgrimage. Rather, the book connoted for them much more the treasury, the mine, the storage room, the scrutable text. And so I think that while the latter way of reading presents us more with something that's quite close to the idea of a query, as we query a database, the former seems to have worked more along the lines of the quest that we are interested in. Now, for most of the time of the Divine Comedy, Dante the pilgrim walks. And even if guided by Virgil, he must walk this walk himself. And so a guide can help us in paying attention to things or putting them into relation with each other and how they speak about the world. And so with some algorithmic combinatorics, we can see the path that Alro would take to visit its high places. And so if we go with this kind of reading setup, then we see how there are moments between these points that actually Alro has something to say, and then all the things in between which are topologically close, but are connecting these things. And actually now, as we speak, I'm trying to let this run in the background. And now we start seeing how there's this kind of book that starts being populated by all the things that Alro, the model, picks up from the other model. We can see the things in bold that are the things that Alro speaks about. And then we see the things in normal plain font, which are the things that are picked up from the map itself. And so in there, sometimes we have sculpture, sometimes we have things, and we have materials, we have aerial views, we have all of these different things. And then, of course, all of these elements that are picked up, they don't come only by themselves or alone. They always come in a multitude. So they come from deep of this kind of neural net, and then they're being shown to us in this notebook. And we make this a bit wider. We can start seeing that everything is kind of hyperindexical. If I click on something, then it should open up the link to the material base. If I click on a 3D model, it opens up in here. If I click on something like this, it opens up in my Zotero on the right page. So it's kind of a nice way of thinking of how to conduct research using these neural nets. But then, of course, walking is only one way of traversing something like this. So, for example, we spoke that with Beatrix, Dante actually flies through the heaven. And there's also a moment where he flies with an eagle a bit in Purgatory. So we can code ourselves also a kind of a pair of wings, and then with which we can fly on our topography outside of the topological relations of it. So we are jumping from one place to another. So now we are following the spectrum of Alro much closer than the spectrum of the map, if that makes sense. And we proceed directly to these high places. But what I just showed here is just a start. So over the next weeks, I'm planning to develop a kind of another model, another meta model, or a schema or a framework to undertake multiple, at least 100 to stay in tune with the cantos in the Divine Comedy of these legs of this quest. And each sequence would then show me sections of the Vectorial world that I'm interested in. And some of them are by foot, others are by flight, others are hybrid, some are guides, some are maybe quested alone, some will be indexical, some will be generated. And I think that is playing through these multiple levels of abstractions in dealing with models whether they are more indexical, like a self-organizing map, as we spoke before, or more generative, like the ones that we saw already today when we speak about Stable Diffusion, Midjourney, and so on and so forth, I think is very key to abstract away from common use paradigms of how we might use these things. And so now towards the end of the lecture, I actually want to show two small things, two small projects. The first is something that Adil Bokhari and me developed as a very simple meta model or scheme for a project titled Automata at Code, in which a large language model and a text-to-image model role-played several roles through a table, then to, in the end, inhabit a full structure. And then in this latest installation, I worked also with Adil and Miro Roman from also the chair of digital architectonics here, like not here, but there in Zurich, to let us transport us, as well as hundreds of visitors that came to this exhibition, to 1001 places. And here, this kind of schema, quite similar to the table that we looked before, allowed to play neural nets by finding very discrete obstacles around which then these tables and windows could be crystallized from this very continuous latent space into these very discrete things that then would be rendered and shown in screens in a very concrete location in Zurich. And so every 30 seconds, we as visitors would experience a completely new time of day and a new scene with a new view out of window. And then every 8 minutes, we would step into a new synthetic day. And then, of course, this goes towards this idea of thinking of a schema through which we can start conversing with these neural nets to tease things out of the latent space that are not generic, but are interesting us as designers and architects. So now I hope that I have showed you a bit of an outline of how we might think of such a quest in the vectorial world. And all of the things that were in there, so the researcher, the hero bottle, the guide specters, the divining rods, and all the other coded helpers and schemas are now ready with this sifted cosmos of things awaiting them. As we quest this new world, we tell us stories of what we find. We might even sing. This is when the quest then becomes properly epic. This year, I'm putting this method also to a test at ETH Zurich, where students train their own guides to explore the multimodal corpus that I prepared, and then to think of ways of bringing it to life. In this sense, I hope to have shown how the mechanics of this quest abstracts away from the digital query to free our eyes and hands up for a new kind of architectural research and practice. It aims not to exhaustively, but to intelligently discovering modes in which digital, technical, natural, as well as vectorial things make up our world. And with this, we can start thinking about how every piece of architecture we design becomes inadvertently a model, bringing together things, the vectorial and the digital, the technical and the natural, the probable and the improbable. Thank you very much.
Questions?
When I feel bad that I'm on the wrong side of the room, so I might run over there too. Do it. Like this hurt my arm. I will tell. I will make. Okay. It's like her arms are gonna be. Yeah, right tomorrow. MVP. Yeah, exactly. Super interesting in general. Like I mostly want to just play around with it because like the idea of getting access to the data set and like getting to find your own way through that is very exciting. I also love just the kind of the idea that everything is really just vector math, like the more we think about it. But in this journey, whether walking path or the flying path, I wonder if there's an opportunity where it might be, showing things that are on your path, but also might show you the direct opposite of if you were on the opposite journey of whatever that might be, like, and then so that you could compare instead of just like reinforcing the same path that maybe, I don't know. Yeah,
I think this is a beautiful idea, and I in a past experiment, I played around with this actually in a course that Ricardo taught, who's also here, with like doing kind of an opposite search engine that shows you always the opposite of what you're looking for. The problem is though that there's something quite funny about how there are things that are near you and they are close to you, but opposite could be literally everything. So this is kind of like the things then start to become sometimes incredibly funny, but also like I had like a little experiment like Robert Venturi going to, I think, to Wikipedia. And then the things that Bob, because I think it's quite important to differentiate between the model and the real human being. So Bob would pick up certain things that would be close. There would be like, I don't know, Baroque houses in St. Petersburg. I mean, that made complete sense. And then the opposite was Bugs Bunny's birthday ball, I think. And it was kind of, on one hand, and then I'm not even sure if he would have hated that, you know? But it was kind of like just from the cosine distance, the most further away thing to think of in this kind of like already dimensionally reduced vector. So it's super exciting to start thinking of this opposite, but like it's sometimes very surprising and not at all what you think sometimes, because it could be everything. Yeah, but I'm very excited to play around with these things, also thinking of like, other kind of encounters that are actually be on the sides of the path, or even characters that have a slight, play a role that are not your friends, but they're actually looking to get you off the path or showing you things to make you deviate. But the beautiful thing is that like with these codes that we are working with at ETH Zurich, they are quite, they're algorithms that have been around for a long time. They're not deep neural nets, so they're quite shallow in that sense. But what is beautiful about them is that you can still use them in connection with deep neural nets, and that you have a possibility of actually coding quite hands-on the models that you're working with. So there is this possibility of actually hacking something to some extent to make it work for you and to really play it, which sometimes with the massive models becomes very tricky, because you are given a black box and then you can tune it or fine-tune it, but you don't have the possibility to just turn it around or make it work in a completely different way.
I have a question. I was wondering, I enjoyed your talk. Even if I saw part of it before, it's always like I always see new things. It's always very enjoyable to see your work. And I was wondering, because you spoke about things and things, and about hyper objects or objects. And I was wondering, how do you think about the difference of things and objects or hyper objects, and if it's something similar to the difference between Robert and Bob?
Mm-hmm. That's an interesting one. Probably this, I have not thought about it in this constellation, but like I think there is something there. I think something which is beautiful about this idea of thinking of the natural object or the technical object with Simondon, or the digital object with Yukui. The problem is that like these things, they remain objects to some extent, even though in Simondon there are already these moments where he wants to see these objects not as these things that we place in a safe distance and then say you are an object and I'm a subject, but he sees them as a kind of instrument to look at the world. So he decries that there's not enough technicity to actually make sense of the technical objects that surround us, and by doing so we kind of falling for either like singularity narratives when it comes to technology and being afraid of being taken over by robots, or on the other hand, to see these machines as slaves. And then this is actually written in 1957 or something like this, which is kind of insanely clairvoyant if we are thinking of the discussions that we are having today. And with the digital object and the vectorial object, I think what I'm trying to explore is to bring some of this idea of this object, which is beyond this object versus a subject, but like more something which is like an instrument that relates you to the world, also to the realm of machine learning and vectors. Because I think that there is something that makes, at least in the idea of the things world, where we start thinking of the thing, especially like in this Heideggerian moment, that the thing is kind of like connected in the fourfold of the world, and so by that the thing, not the object, has a kind of fixed place and is in a relation with its environment, whilst the object is kind of devoid in a vitrine and closed off and all of that. And I think that with the vectorial object, because actually these things exist as vectors in a massive space that indexes everything else in the world of that model, I think is actually quite close to this idea of a thing which is by default relational and not a separated thing for itself. So I think that like with this idea from the natural object to the technical digital vectorial, I think we get closer to the idea of a thing as a relational thing than getting away from it as an object versus a subject. Yeah, but that's an assumption.
Well, thank you for the presentation. When I was listening to you, it made sense, the diagram that you have with the spiral to go to hell and then to climb and go to heaven, because I'm seeing how beautiful you're articulating the relationship that this, what we're talking, is not new, right? This way of thinking, it's already been there. So humans have been always intelligent. So we cannot claim that all these things that we're seeing right now, it's only because we have computers and only because we have computational power. So on that line of thought, I've been thinking about how all the big tech and all of this push and funding is going into creating these multimodal predictors, which is what we're seeing with ChatGPT and Midjourney and so on. But you're doing the same approach, which is creating this multimodal fusion for creation. So I was very curious to know, how do you really, because you're saying everything is indexical, everything then is related with something else, how do you decide to turn that into the thing? How do you, like I'm thinking it's easy for these big tech and companies to say, I will predict what's the best product to buy based on all these different multimodal data, but then you're saying, I'm giving you the same technology, this, this beautiful way of thinking for creation. So how do you decide what to create? What will be your creation with this? That more or less will be my question.
Wow, that's a big one. Also because like it's, I mean, personally, like now being a PhD student, it's like, again, I feel a bit more distant to my role as an architect or designer, which how I worked before, like also designing with intuition. So I think that there are different I think scales to this, like what is the role, and I think we touched also in Benjamin talks a bit about the idea of the role of the architect and the designer as these neural nets kind of are coming about. And I think that there are like multiple things that we need to think about. On one hand, there is this the narrative that, like, of course, these neural nets might take away our jobs. They might make nicer images that we could render in way less time. They make write better emails that we could ever write. So like on one hand, there is this kind of fear is real, and it's probably also right to be worried about this. What, especially in my experiments with Adil and with Miro now at the chair, what we are starting playing with is kind of, can we invent a new way of working with these that is outside of the normal way of using them? Because like if you're using them, you're a user. So like you're kind of being designed for by normally a big tech company to use it in a very certain way. I was working as a UX designer for a while, so I know roughly how that works. And I think as an architect, it's always nice to kind of go to the seams of these experiences and to start thinking and making a world in which you can play with these things rather than use them in another way. So I think that there's this moment of, let's say, creativity or invention spirit for the architect, where we can go on another level of abstraction, and we can start, despite not having the computational power, despite not having the massive teams of AI developers, despite all of these things, we can start speculating, okay, we take that these things are for granted and that they exist and that they work well and they work better than what we could code them as architects. But we can take the liberty to start thinking, how would we play them differently? What stories do we want to tell? And then start using them in a way that maybe nobody ever intended them to use. And then this gives us a bit of freedom and a bit of exploration. Thank you.
Thank you so much. Very thought-provoking, and there's so many things kind of running through my head. I think part of the issue, of course, with search engine is that they're controlled by these large corporations, and I think this is a kind of way for us to establish our own relationship, our own priorities, right? This is kind of a tool that allows us to find our own journey through this vast search space, right? But I'm also kind of really interested in this idea of both the vectorial relationships between things, the somewhat reductive nature of it, right? And this relationship to the physical world in which sometimes the Japanese kind of notion of wabi-sabi and imperfection of the physical realm that exists, and we start to, let's say, produce a personal relationship with these imperfections of things, right? And then how does that kind of exist in a world like this when sometimes people get kind of annoyed when your car gets nicked, but nowadays I kind of go, well, that makes it mine, right? In this sort of very personal sense. So I'm kind of very curious about how do we imbue this sort of sense of personal relationship to these things that we start to collect.
Yeah, I think this is very nice. Very nice. I mean, it's also thought-provoking for me to think about this, because I think that there's a moment in which the way, I mean, this gets very philosophical and I'm a bit out of my depth, but but of course, if we start, I mean, first, I think that these vectorial objects, I think they are never kind of absolute. They're always in relationship to a kind of a space that was established by a kind of algorithm to host these things. So that can be a 10,000 dimensional space of words. Then it might not have the 12,000th word in it, so it cannot account for it. And then even if we would want to work with a 10,000 dimensional space, and we would reduce it, then the vector that we would get out of it would be a vector that was done with an autoencoder, or it would be done with an LSA, or with a NIF, or a different method. And so these vectors, I mean, the clip vector for this chair, yes, that's what clip thinks of that chair, but that's not what another model might think of it. So there's not a singular vectorial representation for all the things around us, and I think it's very important to remind ourselves of this, that there is not this absolute reference point. Even though, of course, there will be probably companies and models that will be so successful that they might become a kind of a reference or a standard.
Well, all models are wrong, but some are useful.
Yeah, exactly. Yeah. But then on the other, let's say the more personal part of how we start to see our world, I mean, I think that the way that we scratch our car, and then by doing that, it becomes a bit more our car because we have another story to tell about that car. I think this is a very nice way of thinking about how also the way that things take place in our reference space that we have, which might be completely different, working in a completely different and not mathematical way, but still it will have, we have models of the world and things have places in this model. And if I scratch a car, then it's only bad because I have something in me that says that's the value goes down of the car, this was a mistake, I should have not done this, why am I so clumsy? And then these kind of things, they start to play, of course, into the weighting of how I see my car. Or on the other hand, if there's a nice story of how the scratch came into the car, it might also elevate the car. But so I think that not just the models, the computer models and how they see the world, but also we have our own models, how we see the world, and they are kind of dynamic and in constant relationship with each other.
Another question.
Please.
So thinking back to the beginning of using language to explain the color orange, or the process, my mom teaches color theory, so I was thinking a lot about that, but also in her telling me that in the Russian language, there is a different color name for light blue. And so if you ask Russian children to pick out when does it become blue versus light blue, it's a very obvious line of delineation between those two things, versus in English, that's much blurrier. And so I wonder about in the initial stage of everything can be encoded into language, but which language? And that in the beginning also of you saying that students or someone was tagging some of these things and not necessarily in English, but then that being translated. And so I wonder if you have thoughts on like how that influences the rest of everything, kind of.
I mean, 100%. I think that's a very good and also tricky thing. Like I like to say this is, you could also say this is a large English model because it actually is. But like I think that that like I think it makes sense to think of this as language, because like language as a category, I think if you would have enough data to train this on a completely different language, and this language would have been spoken by intelligent beings, then that intelligence would have probably also find their way into the model. So I think that like even though we have the large language model now, like these big models trained on English, there's nothing that would prevent us, and I would be very, very surprised to see if it would be a completely radically different kind of intelligence that comes out of it. But it might be different, and it would, I think, still work though. Like it's not that like it's just the English has so much material on the web that allowed for this quantity game that was important for English. And it's quite interesting to see how a foundation model of OpenAI, which is trained mainly on English, can then through fine-tuning and through additional training start to pick up other languages that have way less representation in the internet, and to start conversing in these languages as well, very satisfyingly. And yeah, but the question, of course, remains, like, what would happen if we would train this language model on the language of, let's say, an animal language? Yeah, what would, I don't know what would happen, but it would be very interesting to find out.
Can you push that question further? Say if we have two large language models, if the goal is to find the most efficient way of them communicating, how do you imagine that language to be?
I mean, there was, I think, once this experiment where I think two language models were released to speak to each other, and then after a while they started speaking strange gibberish that like no human could disentangle, because they found a way of communicating kind of concepts to each other in a very efficient form that is beyond the way that we speak, for example, in our English grammar. So it's quite interesting to see these things unfold. But I think that's the beautiful moment of these this AI, is that like we learn a lot about ourselves as we start looking at these models, because we get a kind of an objective distance to how we see and speak and learn about the world. And then, how do we learn from these things without anthropomorphizing them? I think that's the challenge.
I was wondering, concerning this question on language, now in English, because you had Dante as a reference, and now Dante doesn't write in Latin, which would be the English of the time, no? He just writes in Italian. So I was wondering if what somehow you were showing can also resonate with Dante in that sense, that you are kind of developing a digital vernacular tongue. So it's not by abstracting from the Latin/English language. Mm-hmm. Latin language that, by the way, is like also contains a kind of resonance with latent. But yeah, so using English as a latent language in that sense.
That's very interesting. Yeah.
It would go also with your matterings, perhaps. I don't know. That might be
it's true.
Very quick. Right.
I think I would need to think a bit more about how this would work, but it's a great idea. Thank you.
I'll try to keep it short. As a musician, it's very interesting to talk about this, because we're talking about this idea of quest or journey, and there is a temporal aspect to that that's often, connoted, associated with it. But when it comes to this discretization into thingness or objectness, I find this very interesting, particularly in modes of creation where we deal with more continuous time series of states or things. Or this is something that I'm going to ask about, is when we try to distill these more continuous temporal processes into language, right? There has to be a minimum time scale at which we discretize it to be able to attribute language to it. Or, the other thing is when we think about knowledge production and storage and transmission in terms of the body itself, how do we discretize that massive network, analog network of all of these different questions? So I wasn't quite fully formed on the question yet, so I apologize. I guess I'm just interested in how you would adapt this sort of a system to these more analog temporal processes and temporal modes of creation, and how do we capture that experiential aspect of what it means to be human and walk through the world and interact with objects and things that we, attribute names to?
Yeah, I mean, this is a great question. I think there are a couple of points I think to unpick. On one hand, of course, the second leg why this whole thing is working is because of mathematics, because like there are frequencies. I mean, that's kind of cool that like all of these dissimilarity things can only work because actually all of these words, they start being encoded into a domain, which is a frequency domain of, I mean, in this case, it's like term frequency, inverse document frequency, which is kind of quite a robust and also well-tested algorithm. And then these frequencies, they then are the vectors that we are speaking about. And yeah, sorry, and then these frequencies, of course, there is a way of doing that without actually having the whole language in the loop. Like we can we can encode a piece of music based on the pitch, for example, and how the pitch changes. We can change but like I think like we can encode it on many different ways, and like this is a bit like alchemy, like how these things work. There is not really a perfect solution. If we work with like images, then we can take RGB values and we can take a neural net that looks at concepts, and we can take a neural net that is multimodal, and we can put all of these vectors together, and then we have something that might just work. So like it's not like there is a perfect way of representing these things in vectors, and I think there will also not be necessarily only things that work better than others from a pragmatic point of view. I don't think that we can, and all of these vectors, they're always, as far as at least in my knowledge, most of them are, you can never get the original back. So like they are basically a radical compression technique. So I think that like you can never kind of, you sacrifice a lot of the piece of music as you vectorize it. You basically sacrifice all of it because you cannot listen to it. It doesn't make sense. It's compressed in a way that like only picks up certain things like the pitch or like the bass or like the beats or like the tempo. I mean, I don't know like how Spotify has a couple of 6 or 7 metrics like danceability, energy, and some of the other things. Based on that, all the songs are encoded. So I think that when one starts to look into how these things work a bit, it's kind of very clear that it's kind of a fantasy to be like, oh, like there will be the perfect way of capturing this. There will just be ways that are better suited for certain users and others for not, and others and others none. And then I think that there are simple domain problems, like there is a reason why we listen to music and we don't hear the music spoken in words. I mean, then that would be maybe something else, but like it would not be music, right? So yeah, there is a like mathematically it would not be an isomorphic mapping from music to language, 100%, never. And like I think that's with more the things that are encoded in this corpus. Even the sentences themselves lose a lot by going into this.
Just to add on that, I think it's very much kind of in line with what Nickl asked in the previous presentation, the thinking of complex planes and real planes. There's not necessarily, I think, a need to be able to fully represent an actual object that we speak about through an encoding in a digital thing. We don't need to appropriate it in the digital, but it's more about being, like you said, what's the most useful way of representing that in a vectorial space for the means that we want to talk about, which is exactly what Nickl was also talking about, where it's about the proportionalities and the adequacy of making these things talk. And then it's not so much about making an isomorphic projection that is completely internalized within the digital, but that it stays as a representation. It's not an internalization.
Yeah, I agree.
All right. Thank you very much,
Thank you
Agostino.
very much.
Thank you.
That's good.